the first three examples, the A, B, C, for this part, they are the same function. The f of x, I'm going to use another pen here. F of x equals 1 over x as a function notation. Your goal is to find the limit as x approaches 0 from the left part A, from the right. So this is the left-sided limit, and this is the right-sided limit. And part C is the wrap up, which is the two-sided limit, because no superscript. Now, for the function, since this is not a polynomial function, can you tell me what is the restriction for this function? What case that you cannot compute the value for this function?
So we cannot block the x. Like we cannot put the 0 on the 1 over x.
Right, x cannot be 0. Thank you, Min. So x cannot be 0. So basically, the graph will not have anything where x equals 0, or the function is not defined. But for this example, we're going to find the limit as x approaching 0 from the left, approaching 0 from the right, but slightly less than or slightly greater than, and see what happens for the left, for the two-sided limit. Okay. For our convenience, plot the graph and see what's going on. We know that at the point 0, it cannot have anything happen. So going to be the vertical asymptote. Okay. If you put 1 in the x, you're going to get 1 over 1. You put 2, going to be 1 over 2. So the graph will look something like this. And it's called the reciprocal graph. Just to verify, I'm going to use this mouse to show you real quick one more time. Okay, I'm going to do this and this. And change the function name to 1 over x, 1 divided by x. See the graph? It's called the reciprocal graph, and nothing happened at x equals 0. So I'm going to put in x equals 0, and the format. This one, the format in the dotted line in red. Okay. So you can see nothing happened in the middle there. There are two pieces of the graph. And we are going to find out, okay, what if I put in the function as 0? It's undefined. So it's confirmed you that nothing happened there. Now we are going to, I'm gonna do the snap to again, new, and bring it to the content that we have.
Okay.
That's the same as what I drew, okay? So paste
Yeah, version.
through. Oops. So in front of the text, okay. It's a big one. All right, just to confirm when you find the value. Now we're gonna find the limit as x approaches 0 from the left. From the left side, the graph approaching
Down.
going down. So what would be the notation to represent when the graph goes down without bound?
Negative infinity.
But negative means the going down. Infinity means without bound. So now we have the left-sided limit. So similar way for the right-sided limit. As x approaches 0 from the right side, the graph approaching positive infinity because it's going up. That means increasing way. So positive and without bound infinity. For the positive infinity, you can write just infinity. It's understood to be positive. Okay, so you can omit the positive side. We see the direction of left side and the right side of the function. Part C, just to wrap up, what is the two-sided limit?
D and E something.
D and E, because both sides, they don't agree to the same direction or even the same value. So then we can see it does not exist. Okay, for the two-sided limit.